Hello guys, welcome to my channel. This lesson we will learn about differentiation. In last chapter, we have learned about the conic sections. So, if we want to find the tangent to the curve at a given point, we can express this tangent line using the given point, and then let gradient be k. So we solve this line and the conic simultaneously, so we get a quadratic equation, and then we let discriminant equal to 0, so we can get the gradient of this tangent line, so we get this line. For example, if we use an ellipse to represent this conic, and we want to find the tangent to this ellipse at point A, and A is 1, square root of 3 over 2. And this ellipse is x squared over 4 plus y squared equals 1. So, simultaneous equation. We get a quadratic equation. And then let discriminant equal to 0, we can find k. So we get this tangent of this ellipse at point A. But what if the curve is not a conic? So at this time, we need to use differentiation. Now let's learn about the concept of differentiation. The differentiation is a method to find the rate of change of a function. This is the concept of differentiation, and differentiation also gives us the gradient of tangent to the curve at a given point. Now, let's explain the differentiation in detail. We draw a curve on the point A and point B on this curve. So if we want to get the gradient of this curve at point A, if we want to get the gradient of tangent to the curve at point A, we need to move point B closer to point A. So When the point B closer to point A, the gradient of AB is closer to the gradient of tangent to curve at point A. Now, we let x coordinate of A be x. So, y coordinate of A is f of x. We let x coordinate of B is x plus delta x. So y coordinate of B is f of x plus delta x. Here, delta x represents a small change. Now we can get the vertical distance. It's f of x plus delta x minus fx. And the horizontal distance is delta x. So, as delta x smaller, the gradient of AB is closer to the gradient of tangent to the curve at point A. So the gradient of AB is the limit of the expression as delta x tends to 0. So this limit of the expression is defined the gradient function. And the gradient function is the derivative function. So the derivative function is this limit expression. And we can use f prime x to represent the derivative function. So f prime x equals this limit expression. So we found this limit expression Actually, it's the rate of change of a function. So we find the concept of differentiation. Now, we can use this derivative function to find the gradient of a tangent to the curve at a point. Let's take an example. If function is x cubed, if we want to get the gradient of tangent to this curve at point A, at point where x is 1. So f prime x equals limit delta x tend to 0. X plus delta x to the power of 3 minus x cubed. And the denominator is delta x. And then we explain this expression. After simplify, numerator is this. Now we can cancel this fraction. Because delta x tends to 0, so 3x delta x tend to 0. And delta x squared tends to 0. So three times x squared. When x equals 1, f prime 1 is 3. Now we get the gradient of the tangent to this curve at point where x is 1. So this is all content about differentiation. Class is over. See you next time. Thank you.